Basically this idea that if you're pulling carbon out of the atmosphere, it's inherently energetically difficult because you're trying to separate CO2, which is 0.04% in the atmosphere, and like purify it and then put it somewhere. That takes a lot of energy to do that, just fundamentally. And so we wrote a paper about why trying to do that is very expensive and why we kind of need to leverage nature to do that heavy lifting, because nature already does this for free. They do it with plants and trees, where photosynthesis pulls in CO2 and uses solar energy to upgrade the CO2 into the structure of plants, like lignin and cellulose. The only problem is those plants die, and then when they die, they re-release all that carbon back into the atmosphere, and that's the so-called fast carbon cycle. Our realization was, because we've dug up a bunch of old trees and burned them, we can actually now do what happened 300 million years ago during the Carboniferous period, and we can actually prevent those trees from decomposing and basically bury them back underground, like what created all the coal in the first place.
What is the Carboniferous period for those of us who are not geologists?
Yeah, so I love to reference this because it's a great analogy to what we're doing. 300 million years ago, there was a 60 million year period called the Carboniferous period, where nearly all of our coal was created. And so the theory, there's still some debate, but the theory is that all of these ferns, because there weren't trees yet, started to grow into trees. They discovered how to make lignin, which is sort of that bark outside structure. And that lignin protected them from microbial attack and allowed them to grow tall. And so they grew into these tall fern-like, tree-like structures. And then they died and they fell over. And for whatever reason, they started to get buried and turned into all the coal deposits, essentially all the coal deposits we know today. Now, oil was created in a different process with plankton and algae in the oceans and sinking and things like that. But all the coal, which came from these tree-like structures, happened during this 60 million year period called the Carboniferous period. And so it's kind of wild to think about all that happened. It sequestered all this carbon, and then it stopped after 60 million years, it stopped because there's two theories. One is that these microbes, these fungi, actually figured out how to break down lignin at that time. And so these trees, once they died, they started to decompose and they weren't protected anymore. And then the second theory is that there was more sort of subduction activity, more burial activity that buried these structures and kept them permanent. And it was probably a blend of both, but yeah.
Wow, the things we learn on this podcast, man.
And so that's what Carba's doing. We're essentially recreating the Carboniferous period, but we don't have 60 million years to solve climate change. We have more like 100 or even less. And so we need to spend money on decarbonization, and we should spend the bulk of money on decarbonization. But today we spend about 99% of the dollars on decarbonization, and that's switching, off of fossil fuels with things like solar and wind and nuclear and geothermal. We only spend like 1% to 2% on carbon removal. That number needs to go up because that needs to be a sizable fraction of what we're doing to prevent the worst effects of climate change.